this go through? Okay, cool. It's because I get blocked and I have to like unlock it for a while. Yeah, I don't know. It is what it is. Where's my slideshow? Cool. Okay, so we did sampling distributions. Like I said, I don't use these too much because they're new. I don't know them very well, but I'm gonna go through it because there's some really good problems. Oh, it was in the other class. Some really good problems on there. So here's what we're talking about. These guys are means. They're both means. This is a sample. This is for population. So it's a statistic parameter. This is for proportions. This is a sample. This is a population number. Okay? But here's what you need to be able to do. Okay? You need to be able to tell the difference between the parameters and the statistics in a problem.
Can you go back really quick? Just to look at it again.
Not quick enough? Okay? And Deja, if you miss anything, it's all on YouTube. And it's on Twitter too, right?
Twitter.
Oh, what do you guys say? At me, bro. At me at Twitter.
What's that?
Water's really yummy when you're thirsty.
Like after practice, like when you're eating dinner, it's like, oh,
that's
after
my life.
practice.
I couldn't find my little barrel. Remember the little half gallon I got? I couldn't find it. I'm gonna borrow this. Okay, so you should have had this from yesterday.
Yeah.
So let's take a look at this. No?
Yep. Yeah, we do. It's just weird.
Yeah, we did. Okay.
Worded weird though.
So let's take a look at problem A here. What we need to do is we need to be able to identify first the population, second the parameter in here, the sample number, and the statistic in each of the following sentences. So A says, the Gallup poll asked a random sample of 512 U.S. adults whether or not they believe in ghosts. Of the respondents, 160 said yes. So let's start with the population here. What was the population of interest?
U.S. adults.
U.S. adults. It was U.S. adults because that's who we asked. So there it is. That is your population of interest, U.S. adults. What is the parameter here? What parameter are we going to be using?
Is it not one?
Which one?
Is it not one?
We will be using a parameter. Are we going to be using a mean or a proportion?
Proportion.
It's a proportion, so we're going to be using P for this. Okay, and what is P? Yeah, well, this would be the true proportion, but we don't have one right now. You're right, so we don't have one. What we do have is a P hat. We have, what is it? 160 of 515, and whatever that is reduced, that's your P hat. Now, what you do need to understand, though, is that because we are using statistics, then P hat is going to be our best estimator for P. Okay? And it's set to be a very unbiased value, because if we're doing the random samples, then there should be very much or very little bias in there. So it's the best thing that we've got. We use P hat to estimate P. And I think you probably see in your formula sheets, they'll tell you the mean of P, what? Is P hat, okay? Because that's your best estimator. But in this case, that's what we're using. What's the sample? 515. And the statistic in this case?
The proportion.
It's going to be that proportion that P hat. Okay? Questions on any one of those? Let me use another color for the bottom one. Okay. Part B. During the winter months, the temperatures outside of the Starnes cabin in Colorado can stay well below freezing for weeks at a time. To prevent the pipes from freezing, Ms. Starnes sets the thermostat at 50 degrees Fahrenheit. She wants to know how long the temperature actually gets in the cabin. A digital thermometer records the indoor temperature at 20 randomly chosen times during a given day. The minimum reading is 38 degrees Fahrenheit. Okay, what's population of interest? What is it?
Temperature.
The temperatures of
Inside.
inside of the cabin. Cool, right on, very good. What's the parameter here? What would the parameter be? P or mu? Yes. True. Mu, because it would actually make sense, right? Here I can add up all those and find the true average temperature. Okay, so that would be a mean. It's not a proportion because proportions would be falling into categories, right? Proportions are for categorical data. The means are going to be for quantitative data. So our parameter is going to be mu here. Let's see here. What's a sample? How many of them? The 20 randomly chosen temperatures throughout the given day. And what's our statistic?
That's not really.
They don't have the information there, but what would it be? It would be our X bar. Okay. So up there, this would be our parameter. This would be our statistic. This is the parameter. We're searching for the true average temperature, but we're going to get an X bar based off of these 20 temperatures here. Okay. Cool beans. Let's look at it a little differently. Okay. In these problems, they put two numbers in bold. One of them is a parameter, one's the statistic. The statistics. On Tuesday, the bottles of Arizona iced tea filled in a plant were supposed to contain an average of 20 ounces of iced tea. Quality control inspector sampled 50 bottles at random from the day's production. These bottles contain, on average, 19.6 ounces of iced tea.
Gas.
Rip off. You know what's funny is one year I was teaching statistics and there was a kid's like, no, that's not true because the machines, because we're talking about the distribution, and say, you're saying that I could get a soda bottle that's half full based off normal distributions, right? Because could that happen? And like, theoretically it could happen. He's like, that's bull, I call shenanigans. Within the week, he bought a soda at the Coke machine, and guess what happened? He brought it to me and said, Munoz, WTF. It was like halfway full. And he left it for Pepsi and said, or was it Coke, and said, I want my money back. And he left the bottle there with a little sticky, and I was like, dude, that is so cool. Like karma, right? Like man coming at you.
We should go after the chip companies.
Yeah. And Eddie Cassidy, do you guys remember Eddie Cassidy?
Yeah.
Yeah. So anyways, what's the 20 here, guys? That's the parameter, because that's what it's supposed to be. That it's supposed to be 20-ounce bottles of iced tea. You're supposed to have that. That's when you get it, you expect to have 20 ounces in there. So that is the parameter. What about the 19.6? That's going to be the statistic. Okay? Because can that 19.6 change?
Oh, yeah,
Yes, I'm messing with you. 20 is static, guys. The bottles are supposed to have 20 ounces in it, right?
Yeah.
He got 19.6, but that was based off of the 50 bottles. If he grabbed another 50 bottles that were different, do you think he's still going to get 19.6?
Yes.
Probably. Probably not. More likely not. Okay? Because even bottles do follow that normal distribution, okay? And there are mistakes sometimes. 2.2. On a New York to Denver flight, 8% of the 125 passengers were selected for random security screenings before boarding. JP was one of them. According to the Transportation Security Administration, 10% of the passengers at this airport are chosen for random screening. What is the 8%? That's the statistic this time. That's the stat.
I looked say they were chosen.
I can't say statistic very often. And the 10% would be the parameter, because on a typical day, what percentage of the passengers do we expect to be screened? 10%. In this case, we only had 8 because it was out of 125. So you guys see the difference there between those two bad boys? Yeah? Okay. And that we've talked about that changes because of sampling variability. One set of 20 can have very different statistics from a different set of 20 or another set of 20 because of this thing called sampling variability. It's just a bunch of little samples. Sample, samples. And this would be, what would this be bad boy be called? That would be the sampling distribution. Okay. We already talked about that. Is there a question? Did I see that?
No, it's just
Okay. Oh, that was cool. Suppose I have 200 chips in a bag. 100 are red and the remaining are blue. The population parameter of red chips would be 1/2. That makes sense?
Yes.
Why is it a P and not a mu?
Don't know.
Because it's quantitative.
It's kind of local data.
Because it's qualitative, it's categorical. You're either a blue bag or you're a red bag. Okay, I can't assign a number, be like, oh, blues are 1, reds are 2, I'm gonna find the average and get. What? Doesn't make sense, okay? I don't really like these questions, so I'm gonna skip those. Population. Okay, a population distribution, which is the raw data, versus the sampling distribution, okay? A population distribution gives the values of the variable for all of the individuals in the population. Okay, so that's the raw data, that's the original one. The distribution of sample data shows the values of variable for all the individuals in the sample. And the sampling distribution shows the statistic values for all possible samples of the same size from the population. So even though I have one of these, let's say this is it here, all the x's are in there, x, 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 x. How many of these could I make? Yeah, I could make a lot because I can say, you know what? I can make it where sample size is 2, and I would grab 2 data points, and my sampling distribution would be 2. Okay? That would probably produce a distribution that looks something like this. I could also say, hey, you know what? I chose n to be 3. I chose it to be 4, 5, 6, 7, 8. Depends on whatever number happens. But what's happening as this number is getting larger and larger? If I say, oh, you know what? I want sample size 50. How is sample size 2 going to differ from sample size 50?
2 will have more variability.
I will have what?
More variability.
For 50? For 2 we'll have more variability. So sample size 50 might look like this. Okay? I will get much more accurate results. Okay, less variability. Questions there? As sample size increases, variability decreases. Okay? But what's the downside to increasing sample size? Well, if you increase sample size, that's a good thing, right? Because what happens to variability? Goes down, so you get much more accurate results. But there's a downside to larger sample sizes. Time and money, right? If you're going to do more surveys, then you have to pay that person more time. And if you're giving them an incentive for doing the survey, then that's costing you money as well. Even the paper you got to print it on. So, downsides to both of those. Blah! Ink go away. This one's fun. It's like touch it, look, and it just pops away. Boop, 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 boop. Okay, not too worried about that one. Okay, we already talked about P hat being the best estimator, a unbiased estimator of P. Low variability, what do we want for low variability? And per sample size, larger sample size. So here's N100 versus N1000 for this specific sample. Much less variability. Sampling distributions. We already talked about those, right?
Yeah.
Cool beans, and I think that's it. Okay, so here's a quick summary. You might want to take a picture of this, JP.
Yeah.
I know you love taking pictures.
I don't know.
So you can bring your phone out if you want and take a picture. Once you take that picture, put it away.
That's gorgeous.
Say we want to copy it into our notes.
That's really hard.
Well, you can copy it from your phone later on when you're at home. I love that pose. iPhone to the sun.
This is like a
All of it.
continuation
There's
of
so
the
much of it.
last note.
So much of it that I
It's the
just
same thing.
that I just like that. Who does that?
I said a continuation.
You narrate your life. I'm sure we already have all that. Hey, start lighting up.
Okay.
Every time you do something, look at each other.
podium.
Yeah, I see him every time.
Okay. I want to write it a little bit smaller, but that'll work. Homework. Page 428, numbers 1 through 13, 17 through 24.
How many hours of tutoring, or how many sessions of tutoring do you need to go to so you can take that quiz?
To retake a quiz?
Yeah. You can't retake a quiz? That'd be your
You
only
can retake a test.
Oh, there's no way to retake a quiz if you go to tutoring or whatever, all that kind of stuff? Sad day. Sad day. Not what happened after this, not what happened last one.
Which quiz did you fail?
Just this one.
Did you put something that made sense on there?
A little bit, some of them, yeah, but some of them I was just like, I thought that was the word bank, so I was like,
I thought I specifically said.
no, I didn't
Just
get
a
it.
list of words, keywords.
I didn't, obviously didn't hear it right, that's my fault.
And I actually think I actually wrote keywords.
I didn't like keywords like key.
I don't read instructions.
Like, I don't know.